We'll continue with our discussion in the last class. In last class, we learnt about the preliminaries or prerequisites for Newton rings. So, we'll be dealing with Newton rings in detail in today's class. Okay. So, what we have learnt in last class? We have learnt about light, meaning dual nature of light, that is wave nature and particle nature. Wave nature could explain phenomenon like interference, diffraction, polarization, a reflection, a refraction, etc. Particle nature could explain reflection, a refraction, photoelectric effect, and many more to do with. Okay, these are we have learned. Here we'll be dealing in detail with interference because Newton rings works on the principle of interference. Okay, so what we have learned about interference? Interference is mixing or superposing of two or more light waves of different intensity such that the resultant distribution will have a mix of these intensities that are available. We have seen the formula for intensity, resultant intensity is I equal A1 square plus A2 square plus 2A1 A2 cos theta. This is the formula for resultant intensity. A1 is the amplitude of first wave, A2 is the amplitude of second wave, and theta is the angle that encompasses between them or the phase. Okay, so the A1 and A2 are the amplitudes of first and second wave because we have considered only two waves here. This interference is again broadly divided into two categories. The first one is called division of wavefront and the second one is called as division of amplitude. So we have spoken in much detail about division of wavefront and division of amplitude in last video. What is division of wavefront? The light from a single source is allowed to pass through two different sources and they travel unequal distances and interfere with one another, producing bright and dark fringes alternatively. In case of division of amplitude, the light wave that is obtained from the source is allowed to fall on a reflecting or a refracting surface where some of the light wave will be reflected, some part will be transmitted to the second surface which further reflects back and the outcoming waves interfere to produce what is called as bright and dark fringes. Okay. Now, the Newton ring concept works on the principle of division of amplitude. What are the other experiments that work on division of amplitude? Michelson interferometer works on the principle of what do you call division of amplitude. Even the division of wavefront experiment is used to explain many phenomena that are there in our what do you call concepts. What are the phenomena that are used for explaining for division of wavefront? Young's double slit experiment is a popular example from which we can find the wavelength of the incident source of light. So now we will deal in detail with the concept of Newton's rings. Okay. The Newton rings concept is very, very important as far as the division of amplitude part is concerned. What is there in Newton rings? This was invented by Newton, hence it is called as Newton rings. In this Newton ring experiment, what is that we are going to do is, we have a plano convex lens. What is a plano convex lens? One surface is plane and other surface is convex. This plano convex lens is kept over a plain glass plate. So the bottom one is a plain glass plate and the top one is a plano convex lens with its convex surface touching this glass plate. This point where the convex lens and the glass plate meet is called as point of contact, and this one is called as glass plate. Okay, and this one is called as plane part of the plano convex lens. Now what should we do? We should allow some light to fall on it so that interference takes place. Where does the interference takes place? The interference takes place in this part because there is an air film between the convex surface and the plane glass surface. Okay. So what does we do? We allow a light to fall on this. So I have some source of light, say some sodium vapor lamp or something which is monochromatic. Monochromatic means a single color of light or single wavelength of light. The monochromatic light produces a parallel beam of light. This is allowed to fall on a glass plate that is inclined at an angle of 45 degrees with the normal. What is the purpose of this glass plate is, this glass plate will allow these light rays to fall normally onto this plano convex lens. Now, when this light is falling on this plano convex lens, this light which is falling here will hit this surface, that is convex surface, and a part of this will be reflected and a part will be transmitted which will reach the bottom plane glass surface, and again this is reflected and both of them come out here and they start interfering to produce what is called as interference pattern. Since the center part is a point of contact, the center spot or the center image that you get will be a dark one, followed by what do you call as consecutive dark and bright rings. Why they are ring in shape? Because you are getting the images from this plano convex surface, the images formed will be as rings. Okay, hence these are called as what is called Newton rings. Then how can you see or how do you say these rings are visible? So what happens? These interference patterns, they reflect, they superimpose, and you use what you call as a microscope. Here you use what you call as a microscope. The reflected light comes this side and you can see the rings that are forming underneath this. Okay. So what are the apparatus that you require for this experiment? I require a microscope. I require this glass plate. I require a plano convex lens. I require another glass substrate here. Okay. And a source of light. With all these small things, I can produce an interference pattern based on the principle of division of amplitude. Now the question comes, how are the Newton rings formed and how to calculate if they are ring in shape, how to calculate their diameters, how to calculate their radius, and what is the use of knowing their diameters and all in the subsequent lecture that we follow. Okay, so this is a plano convex lens, and again I repeat, this is a plain glass plate, and this point is called point of contact, and this is another glass plate, and this is a microscope with a sodium vapor lamp. Okay, now we will try to explain the concept in more detail. Okay, so what is the explanation that we are going to do? Newton rings are formed due to the phenomena of interference in this region. Why in this region? Here you have a gap that is trying to produce continuous rings. In this gap, what is the medium that you have is, you have a air film. Okay, so this air film is important. When the light is falling here, the light reaches this surface normally. So when light falls normally, you would have studied in your class 8 or grade 9 that when light falls normally, it is reflected back also normally. So the resultant reflection can be watched through this microscope. Okay. Now we will try to understand this in more detail using what is called as this picture. This is the plano convex lens and this is the glass plate. They are in contact here. I'm sorry. They are in contact. This is called point of contact. So I have a light which is falling normally on the surface. It will reach somewhere here and this light is reflected and this will come out. I will call this river. Other part of this light is transmitted to the bottom and it gets hits back here and it comes out as secondary. Remember, the one light that is hitting this glass plate is reflected, suffers a phase reversal of 180 degrees due to the reflection. Here you will not find that because of the lens it is getting refracted, and here you will find it because of the reflection at the edge of the glass plane, and these two light waves, they interfere, producing what is called as Newton rings. Now we will try to calculate different parameters that are available from this experiment of Newton rings. So the first one that we will try to calculate here is the path difference. What is the path difference? This will travel some distance, this will travel some distance. The distance between the two waves, if you can calculate, from that we can find what is called as bright ring or dark ring. So what is the formula for path difference? The formula for path difference is, yes, anybody can tell me? Okay, okay, okay. So it is 2 mu t cos r plus lambda by 2, right? Got it. So this is 2 mu t cos r plus lambda by 2. So what is this mu? The mu is the refractive index of the medium that is present between plano-convex lens and glass plane. What is T? T is the thickness of the air or medium that is there between them. And here the light is incident normally, so R will be 0. So what is R? R is the angle the light ray makes with the normal, and lambda is the wavelength of light, and lambda by 2 is the additional part. So when I take air as the medium, this mu will be equal to 1, and for the case of normal incidence that we have here, R is equal to 0. So when R is 0, cos R will be 1. And when mu equal to 1, this expression for path difference becomes 2t plus lambda by 2. So 2t plus lambda by 2 is the path difference between the two interfering lights. Now we should find out when you will get a brighter fringe and when you will get a dark fringe. So for center spot, it is dark, meaning the center spot, the thickness of the medium or thickness that is present is 0. So when I put t equal to 0, what is the path difference I will get is, the path difference is equal to, put t equal to 0, 2 into 0 is 0, 0 plus lambda by 2. So lambda by 2 will give me what is called as minimum intensity or dark back. Okay, so this is one thing that we need to keep in mind. So then the other thing that you have to keep in mind is, I got a center dark. After dark I will get a bright one, and again I will get a dark one. So then there I cannot have zero thickness, but I will have some thickness. So 2t plus lambda by 2 is equal to n lambda. What is n? N is some number 1, 2, 3, 4, 5, 6, etc. That is an integer. So when you take this integer, what you get is, you get a maximum intensity. You get a maximum intensity. So send that lambda by 2 that side. 2t is equal to n lambda minus lambda by 2, or 2t is equal to 2n minus 1 lambda by 2. This is the case for maximum intensity, or that you get a bright ring. Bright ring means dark, you will see consecutive, alternate darks. In between you will have some gap like thing, that is nothing but a brighter one. Okay, so that is one thing that is important here. Same condition, dark you want to get. What happens for the case of dark is, you will get 2t is equal to n lambda. For the case of dark ring, what do you get? 2t is equal to n lambda. So this is the condition for the case of dark one. For the center one, you will get lambda by 2 minimum intensity, which is dark. And for the subsequent, this is the maximum intensity case. Put n equal to 1, 2, 3, 4, 5, 6 alternate. And this is the dark intensity condition. You keep putting 1, 2, 3, 4 and so on, different subsequent values. We'll continue further. So as of now, what we have learned? 2t is equal to 2n minus 1 into lambda by 2 will give you a bright ring. 2t is equal to n lambda will give you a dark ring. This is dark, this is bright. Put n equal to, this is a integer, 1, 2, 3, etc. Okay. Now we will try to explain this in a bit detail. So this is a plano convex lens. How did you get this plano convex lens? We got it from a very large curvature, what do you call, glass ball that we have made. We have cut this plano convex lens from it. So this will have some radius. This is the center of this large lens, and the radius of this is given by capital R. And underneath this we have what is called as a, what do you call, a glass plate as usual, and this point is point of contact. Now I will take some ring here. The, what do you call, I will draw a perpendicular or the diameter here. Let us name this point as O. Let this point be called as N. I will take a ring here. Ring means it can be dark or bright, whatever it is. I will take a ring here. This point is N. The edges of this are P, and this is Q. And the other thing is, this is the lens, so I'll call this as L and L dash. And this is the center, and I will call this point as D. Okay, so this is Q, N, P, this is O, this is, what do you call, N and D. We will try to use this distance is smaller. Small r is the radius of the ring. Capital R is the radius of curvature of the lens from which you have cut that lens piece. Now there is a mathematical concept on cards which states that this Qn into Np is equal to this On into Nt. This you would have studied in your 9th class mathematics. This On into Nd is equal to Qn into Np. So Qn into Np is equal to On into Nd. So this ON is the height of the film that we are taking. So that ON, we can take that ON to be small t. We know this is a circle. The diameter of this circle will be 2r because the radius is r. So remember, this is capital R. So when this complete is 2r and this is small t, this becomes 2r minus t. And this Qn and Np are equal, which is small r radius of the ring. T is thickness of the air film. R is the radius of the ring. Capital R is the radius of curvature of the lens. Okay. So this is R into R equal to this thickness. T into 2R minus T. R into R, how much? R square. This, if you can multiply, this is 2RT minus T square. This air film thickness is very, very small. So if you take T square, it will be still more small. So we can approximate this as R square is approximately equal to 2RT. From this we can find the thickness to be T is equal to R square by 2R. What is capital R? Again I am repeating. This is the radius of curvature of the plano convex lens, and small r is the radius of the ring with respect to the center dark spot that you have taken. And now we will try to use these formulas, or we will substitute this T values in this bright and dark ring condition. 2 into, for bright one, instead of T you substitute R square by 2R is equal to 2n minus 1 into lambda by 2. Okay. So you try to cancel what are the terms that you can cancel. 2 gets cancelled. You transpose this R to this side. You get R square equal to 2n minus 1 into lambda R by 2. Replace this R with diameter. So what is diameter? Diameter by 2 is radius, right? So d by 2 whole square is equal to 2n minus 1 into lambda r by 2. So d by 2 whole square will become d square by 4. Here you have 4, this side you have 2, 2 ones are, 2 4 2s are. So that will become d square by 2 is 2n minus 1 into lambda by r, or d square equal to 2n minus 1 into lambda r into 2. This denominator 2 will go to that side. So if we observe, lambda is constant because the light wave's length is not changing. Capital R, radius of curvature, is constant, and 2 is constant. Therefore, d square is proportional to 2n minus 1, or d is proportional to root of 2n minus 1 for the case of bright. Meaning root of 2n minus 1. 2n minus 1 means for odd natural numbers, the square root of odd natural numbers is directly proportional to the diameter of the brighter rings. Now we will try to solve for the dark ring case. This is 2t equal to n lambda. So put 2 t instead of t we will write as r square by 2r is equal to n lambda. Both these things gets cancelled. Instead of r square, what we are writing? D square by 4. D square by 4r equal to n lambda, or d square equal to 4r n lambda. Again 4 is a constant, r is a constant, lambda is a constant. So d square is proportional to n, or d proportional to root n. This is for the case of dark fringes, meaning the diameter of the dark fringe is directly proportional to the square root of natural numbers. And for the case of bright rings, the diameter of bright rings is directly proportional to square root of odd natural numbers, because 2n minus 1 will give you odd number.